Alright, hello. So this is the project I've been working on, and I've got the game window open, and I've got it set to be at maximized so that when I click play here, so mechanically speaking, we are pretty much identical to Flappy Bird in this case. We've got what would normally be pipes that are this time dangerous plants, that our paper airplane that would normally be a bird must avoid. And passing through the middle of these obstacles will add to our score counter on the top left. 15, 16, 17. The only difference between this game and Flappy Bird is that if I want, I can hold down like this for longer glides like that. If I narrowly pass through the teeth, I can go past them, but if I hit a wall like this, then I'll get caught, and the game has entered its lost state, where the score can no longer increase. Alright, the game is made up of a few different pieces that we're going to look at. So all these are game objects in hierarchy. We've got the player to start with. The first thing that we had to deal with was getting the player movement set up and the player art set up. The art I made online in an editor called Piskel, where I drew both this and the plants. If I take a look in the script for the player, we can take a look and see what it's made up of. So the first thing that we've done is set up a variable that we can adjust from this whole menu screen in the inspector over here. Alright, so for every frame that the game goes, this runs as though it were a function. We take the current rotation of our plane and we set it equal to itself plus the y velocity of the plane. This is what makes it where the plane tilts down as it's falling and tilts up as it's rising. We multiply it by 2 so that it's a nice noticeable amount of tilt. And then the next thing we do is set our rotation to 1/2 of itself at all times for every frame. This way, the plane, as it teeter-totters back and forth, will always approach facing level. That way the plane kind of has a cap on how far it can tilt. Then we run an if statement here that checks for frames in which the space key is pressed, which is our controls. And then we reference the physics engine here and set the linear velocity variable for linear motion to vector2 up times flap strength. Vector2 up just makes it where we're only referencing the y out of the two different directions that we can move the plane in. And flap strength is just a little multiplier that's also a variable that can be changed in the inspector over here, so that I can adjust how strong the plane is pushed up by the spacebar. Then we run another if statement right here, do it again, so this checks every frame for when the space is down, adds a little bit, but also the initial frame, no flap. This way, when you first press the spacebar, it goes up quite a bit, and then after holding it, it glides up slowly to allow for a little bit of finer control. The next thing we can look at is our spikes here, or rather our spiked plants. So if we look in the scene view, and we look at our spikes real quick, we can see that it's made of 3 components. It's got the top spike, the bottom spike, and the middle. The top spike and bottom spike have little collision boxes here in green that are what the plane can bump into for when we're going to lose the game. The middle is just a little collision box that checks for when the plane passes through, and in doing so, we'll add to our score counter on the top left up here. Once we had the spikes set up, we had to figure out how to spawn them and make them scroll past the screen and make them come in at different heights. So we've got a spawning script that runs a spawn spike function that we made down here. So we've got 2 different values here, which are local variables for the lowest point, which are how much the height of newly generated spikes can deviate. And we've defined the function here to set up our lowest point and the highest point variables first. It's the position that the origin spike, which is this, is set up at, minus and plus spike displace, which is a variable that we've made that helps us control how much displacement there can be between 2 spikes. And then we instantiate, or basically we're making a clone of this set of spikes. We make a new spike that's going to move to the left on the screen, and then we spawn it in at the normal X of this guy, because the X is controlled by the mover script down here that we'll look at in just a moment. It doesn't change anything about the rotation either, but it does set the y value to a random range, the lowest point that we set up here and the highest point that we set up here. This way we generate random y values within this range that the spikes will generate in. This way they don't go so far that they're off screen, but each one is different and it's not the same boring height every single time. So it gives the game its flavor. Then we set the timer to 0 because the timer is how we decide how far apart each spike is going to spawn. What we do is we set up a timer variable that adds to itself after a certain amount of time, regardless of frame rate, thanks to delta, goes by. We'll spawn a spike if our timer is greater than the spawn delay, because if it's less than, then we'll add to the timer. If not, then we'll spawn a spike and then eventually set the timer back to 0. The timer counts up after a spike gets spawned and then resets every time we spawn a new one. By setting the public variable up here that we can edit from the editor, we've set this to be 10 by default. This is the distance between each set of spikes. So as they spawn, this is how long it waits before spawning a new one. Then, once those spikes are spawned, we need to actually do something with them. So we have a spike mover script here. We've got two variables that we've set to be 5 and -9 respectively. So for each frame that the game runs, we're going to take the position of the spikes and we're going to set it equal to itself plus vector3 left times move speed. This time it's vector3 because when we use transform, for some reason it defaults to being 3D instead of 2D, but it is what it is. So then we multiply that by move speed so that we can use this variable to modify how fast they go by. We've got this set to 5 so they scroll past pretty quick. And then we run an if statement down here that checks if the x position is less than the dead zone. The dead zone is the point beyond the screen past which we delete the spike objects so that we don't rack up a bunch of objects off screen that aren't doing anything. We set it to be -9 so that as they pass this value, we'll destroy the game object that we instantiated in the other script. Once we've got all the art working and all the scripts working, we need a logic manager piece that's going to actually help us set the player score. So this helps us set up a player score and it references our little piece of UI here that's at the top left so that it can edit it. Then what we do is for increasing score, we run an add score function. The middle part script will take a reference from our logic manager so that it can run add score, a function that we define here. We define our last little function here, add score. We set a new variable that we've made called player score to itself plus 1. In other words, increasing it by 1 as we pass through the hitbox. And then we'll display that as text in here. We have to convert it to a string so that it can be displayed by our little piece of UI here. Alright, thanks for watching. I enjoyed making this little project, and I learned a lot about both the Unity engine and fundamental programming skills that I'm going to take with me to lots of different places. Hopefully I'll be making lots of games now.